All right, let's talk about different ways of measuring angles. So we have two different kinds of units. One is radians and the other one is degrees. They both measure angles, which is the amount of rotation. And so if you take a look at standard position of an angle, we have the initial side, which is the side that doesn't move. And then we have the terminal side, which is the amount of rotation that is happening when that side moves. And so the terminal side is the side that moves. The initial side stays where it is. And when we're looking at trigonometry, that initial side is always on the positive x-axis, starting at the origin and going to the right on the x-axis. And then your terminal side is the one that swings around with the vertex on the origin. Okay, so we have two ways of rotating that terminal side. When we rotate counterclockwise, we are creating a positive angle. That's positive movement for that terminal side. If you go clockwise, if that terminal side swings clockwise, then that is a negative angle measurement, whether we're talking about radians or degrees. Okay, the next term that we need to look at is called coterminal angles, and that just means that they share a terminal side. Okay, that's why they're coterminal. They share that terminal side, but they have different amounts of rotation and possibly different directions of rotation. So in this first example, we have a positive angle and we have a negative angle that share the same terminal side. So those are coterminal. Okay, then in the second example, we have an acute angle that has that terminal side, but then we have another angle that comes all the way around and then comes back up. So it makes a full circle and then continues to land on that same terminal side. Okay, so those have different amounts of rotation, but they share that terminal side. Now let's take a look at radian measure. We're used to degree measures of angles because that's what we've grown up using. But now we're going to talk about a different way of measuring angles, and it's called a radian. So a radian is found when you take the radius, which is why it's called radian, the radius of the circle, and the arc length that the angle opens up to is the same length as that radius. Okay, that angle measure is considered 1 radian. So if the angle opens up to an arc that has the same length as the radius, then that is 1 radian. So if you do that all the way around the circle, you end up with 6 radians and then a little bit left over. And that's where that 6.28 comes from, which we know is an approximation for 2 pi. So the total number of radians in a circle is 2 pi. So now let's take a look at our quadrants. We have quadrant 1, where we have positive x coordinates and positive y coordinates. And so our angle measures in radians go from 0 to pi over 2. Okay, because remember that an entire circle is 2 pi, and so 1/4 of 2 pi would be pi over 2. In quadrant 2, we have negative x values and positive y values. So in that quadrant, we have angle measures that range from pi over 2 to pi. And then in quadrant 3, we have negative x values and negative y values, and our angle measures will range from pi to 3 pi over 2. And in quadrant 4, we have positive x values and negative y values, and our angle measures will range from 3 pi over 2 to 2 pi. Now keep in mind that there may be coterminal angles that are outside of those intervals, but would land in that same quadrant. Okay, so let's take a look at the degree measures of our angles. And so you can see here that in the first quadrant, we have 0 degrees, we have 30 degrees, we have 45, 60, and 90. And then we can continue around the circle to get all of these other degree measures. Okay, so if we have the degree measure of an angle and we want to convert that to radians, we're going to take that angle measure and we are going to multiply by pi over 180. So let's take a look at this first circle where we have 30 degrees. If I want to convert that 30 degrees into radians, I'm going to multiply by pi over 180. Now when I take 30 and divide by 180, I get 6 in my denominator, and so that's where the pi over 6 comes from. Now if I want to convert from radians to degrees, I'm going to take my angle measure, and now I'm going to multiply by 180 over pi. So if I have pi over 4, and I need to convert that to degrees, I'm going to multiply by 180 over pi. And so my pi's are going to cancel, and 180 divided by 4 gives us 45 degrees. And so that's how we can convert from radians to degrees. All right, so let's take a look at example number 1. Convert the angle from degrees to radians and find the smallest positive coterminal angle in radians. Okay, so again, we need to multiply by pi over 180. Okay, and that's going to simplify to 7 pi over 3. And then we're going to find the smallest positive coterminal angle. And so 7 pi over 3 is more than 2 pi. So in this case, it's more than 1 full circle. So we're going to subtract 1 full circle from that to get the coterminal angle. And so the easiest way to do that is to convert that 2 pi into thirds. So that's going to be 6 pi over 3. And so then we're going to be left with pi over 3. So the smallest positive coterminal angle to the 7 pi over 3 is going to be pi over 3. Now let's take a look at negative 45 degrees. I want to convert this to radians, so I'm going to multiply by pi over 180. And when I simplify that, I get negative pi over 4. And so I have a negative pi over 4, so that's a negative angle. So in order to make it, to get a positive coterminal angle, I need to add 1 full circle to that angle. So I'm going to add 2 pi. And again, if you want to convert that to fourths, that will make it easier when you're adding. So that's going to become 8 pi over 4. And so then when we take negative pi over 4 plus 8 pi over 4, we're going to be left with 7 pi over 4. So that is a coterminal angle with negative pi over 4, and it's the smallest positive coterminal angle. Because the number of coterminal angles with any one of these angles is infinite, because you can continue going around that circle as many times as you want. So let's take a look at example number 2. Now we're going to go the other way. We're going to convert from radians to degrees, and then we're going to find the smallest positive coterminal angle in degrees. All right, so when we want to convert from radians to degrees, we need to multiply by 180 over pi. And when we do that, our pi's are going to cancel, and then when we simplify, we end up with 375 degrees. Now that is more than 360 degrees, so it's more than a circle. So we're going to need to subtract 375 degrees minus 360 degrees, and we'll be left with 15 degrees. So the smallest positive coterminal angle with 375 degrees is 15 degrees. Now let's take a look at negative 3 pi over 4. To convert that to degrees, we multiply by 180 over pi, and then we simplify that and we get negative 135 degrees. That's a negative angle, so in order to get a positive coterminal angle, we need to add 360 degrees to negative 135 degrees to get the coterminal angle that is the smallest positive coterminal angle. And so we end up with 225 degrees. Now let's take a look at an application problem. The circular blade on a saw rotates at 4,200 revolutions per minute. Find the angular speed of the blade in radians per second. So we need to convert this 4,200 revolutions per minute into radians per second. So the first thing we can do is look at a revolution, and a revolution is one full turn of the circle, okay? One full rotation. And so one revolution is going to equal 2 pi radians because those are both one full circle, okay? So now we can take our 4,200 revolutions per minute, so 1 minute, and what can we multiply our revolutions by to get radians? Well, we just said that 2 pi radians are in 1 revolution. And so when we do that, that's going to allow us to get rid of the revolutions unit. So now we have an answer in radians per minute, and we need to convert that to seconds. So how many seconds are in 1 minute? So we have 60 seconds in 1 minute. And so what that's going to do for us is allow us to cancel out the minutes. So now we're going to end up with radians per second. So now we just need to multiply through. And when we do that, we end up with 140 pi radians per second. And typically when you're talking about radians, you can just leave it in terms of pi. Sometimes you might see it in decimal form, but for this, we can just leave it in pi. So now let's take a look at the second part. The blade has a radius of 6 inches. Find the linear speed of a blade tip in inches per second. So we've got our blade and its radius is 6 inches. So what would be the distance all the way around the blade? Well, that would be our circumference. Remember that circumference is 2 pi r. And so we've got 2 pi times 6 inches. So our circumference is 12 pi inches. Okay, and then let's take a look at the comparison of the circumference and the revolution. So we have 12 pi inches in 1 revolution. So every time this blade turns 1 full revolution, it will go 12 pi inches. All right, so now we can do a similar process that we did when we found the angular speed, and we can set up our unit conversion. So we know that there were 4,200 revolutions in 1 minute. So to convert our revolutions to inches, we know that there are 12 pi inches in 1 revolution. So that's going to convert our revolutions to inches for us. And now convert our minutes to seconds, and we know that in 1 minute there are 60 seconds. And so that's going to convert our minutes to seconds. Okay, so then we'll be left with inches per second. And so now we can just go ahead and multiply that out. And when we do that, we end up with 840 pi inches per second. And it's kind of hard to think about inches in terms of pi, so we'll go ahead and multiply our 840 by pi, and we get approximately 2,639 inches per second.